of state of matter and how they relate to heat. Changes of state. This is a physical change. A change of state is a change of a substance from one state of matter to another. A change of state is a physical change that affects one or more physical properties of a substance without changing the identity of that substance. These changes of state include freezing, going from liquid to solid, melting, solid to liquid, boiling, liquid to gas, and condensing, gas to liquid. So you need to understand that in this graph you have ice until it reaches 0 degrees Celsius. This is the melting point or freezing point of water. As the temperature is increasing, it will increase until it reaches 0. But once it has reached 0, we will continue to apply energy as the ice then melts into water. Once all of the ice has turned into water, then the temperature will start to increase again until it reaches the boiling point at 100 degrees Celsius. At that point, we can continue to add more and more energy to it, but the temperature will remain the same at 100 degrees Celsius until all the water is turned into steam. At that point, the steam can then increase its temperature again.
The temperature of the ice remains the same until all of the ice has become liquid water. The water's temperature stays at 100 degrees Celsius as long as there is liquid water present.
So some definitions that you will need to know: melting, freezing, boiling, evaporating, condensing, and sublimating. In the next section, you will need to write down these definitions.
To melt means to change a substance from a solid to a liquid state by heating it to the melting point. Different substances melt at different temperatures. Water melts at 0 Celsius or 32 degrees Fahrenheit. To freeze means to change a substance from a liquid to a solid state by cooling it to the freezing point.
Now, temperatures. The freezing and melting temperatures for most substances are going to be the same. So, for example, water, its freezing temperature and melting temperature is at 0 degrees Celsius or 32 degrees Fahrenheit.
The boiling point is the temperature at which a liquid changes to a vapor or gas. Again, this is a different temperature for different substances. For water, the boiling point is 100 degrees Celsius or 212 degrees Fahrenheit. Evaporation is the change of a liquid into a vapor at a temperature below the boiling point. This occurs at any temperature between the melting point and the boiling point. However, the warmer the temperature, the more quickly the water will evaporate.
Condensation. Condensation is the change of a gas or vapor to a liquid, either by cooling it or by subjecting the substance to an increase in pressure. When water vapor cools in the atmosphere, it condenses into tiny droplets of water, which can then form clouds.
Sublimation is the process of changing from a solid to a gas without passing through a liquid phase.
Dry ice is an example of this. So let's take a look at a practice. And you're going to decide the state or phase for each of the items. So, when we go through it, is it melting, freezing, boiling, evaporating, condensing, or sublimating? So let's do some practice ones. Number 1, in which state is the snow?
In which state is the puddle? Choose 2 answers.
In which state is the fog?
In which state is the moisture on the bottle?
In which state is the puddle on the road?
In which state is the road?
In which state is the moisture on the leaf petals?
In which state is the water in the teapot?
In which state is the ice next to the mountain?
In which state is the water vapor?
Now let's check and see if your answers are right. For number 1, if you chose melting for the snow, you would be correct.
Number 2, it had 2 answers. It's A, melting, and B, freezing.
If you said condensing for the fog, you would be correct.
Number 4, it's also condensing.
Number 5, this time the water in the puddle is now evaporating.
Number 6, the road is clearly frozen.
The puddles on top of the leaf are condensing water.
Number 8, the teapot, the water is boiling.
Number 9, the ice is sublimating.
Number 10, the water vapor is evaporating.
So let's move on to the next part. Factors that influence the rate of evaporation, meaning how fast or how slow water evaporates.
The higher the temperature, the faster the rate of evaporation.
So, in this example, which puddle would evaporate faster? The one with a road temperature of 27 degrees Celsius or the one with a road temperature of 67 degrees Celsius? Which one do you think? If you said the higher temperature B, you would be correct.
The more wind or air circulation, the faster the rate of evaporation.
So which puddle would evaporate faster? The one with wind blowing on it or the one with no wind? If you said the one with wind blowing on it, you would be correct.
The larger the exposed surface area, the faster the evaporation rate. The water will evaporate more quickly from the beaker on the right with the wider opening.
Humidity. When the humidity, or the amount of water vapor is in the air, is higher, the evaporation will be slower. Part of that is because there's already too much water in the air, so it doesn't want as much.
In which location would laundry hanging on a line dry the quickest? Desert, a nice day, a rainy day, or in the tropics?
If you said A, the desert, you would be correct. It has the lowest humidity, and so therefore the water would evaporate the quickest. The next part, factors that influence the rate of melting or freezing.
Remember, the freezing or melting point of water is 0 degrees Celsius or 32 degrees Fahrenheit. The higher the temperature, the faster water will melt. The lower the temperature, the faster water will freeze.
The shape and size also matters. If you have 2 equal masses of ice, but one is a solid brick and the other is in smaller pieces, the one with smaller pieces will melt faster because it has more surface area exposed to the warm air.
Just like with evaporation, the more surface area exposed to heat, the faster water will melt. Likewise, the more surface area exposed to cold, the faster water will freeze.
So in which cup will the ice melt quicker?
I know.
If you said A, you would be correct because the ice is broken up and has more surface area exposed to the warm water.
Think about this. People control the temperature of food by placing it into the styrofoam containers. Styrofoam is a poor conductor of heat. A styrofoam container will not change temperature quickly. This is why when you buy a cup of hot chocolate, it will probably come in styrofoam cup. Your hot chocolate will stay warm longer and your hands will not burn.
So if you place equal amounts of hot water into two containers, let's say one's a metal container, which is a good conductor of heat, and a wood container, which is a poor conductor of heat, the water in the metal container would cool faster because the metal cup would absorb all the heat and take it away from that warm water.
Anytime you place equal amounts of water at the same temperature into two containers, one a good conductor of heat and one a poor conductor of heat, the container made from a good conductor of heat will speed up the cooling of the water by conduction.
So in which cup would you freeze 6 ounces of water the fastest? I know. Do you? If you said B, the metal cup, you would be correct because the metal would cool down quickly and then cool the water down quickly.
Changing in composition. During the cold and icy winter, you have probably experienced salts on sidewalks and roads. It is used to melt the ice and snow and keep it from refreezing. The freezing point of water becomes lower as more particles are added into the point where the salt stops dissolving.
So by adding salt to icy roads, you're actually changing the freezing and melting point of the water from 0 degrees Celsius to 0.09 degrees Celsius salt water. Salt water freezes at much colder temperatures, so by adding the salt to the snow, you're actually changing the freezing point.
Factor 1, temperature. The hotter the air temperature, the faster ice melts. The colder the air temperature, faster water freeze. Size and shape also is a factor. Larger pieces of ice melt more slowly than an equal mass of smaller pieces.
Factor 3, conduction. Water in containers which are good conductors of heat will cool more quickly. Factor 4, changing the composition. Mixing water with other compounds such as salt will influence the freezing and melting point. Put your notes into your notebook so that we can go over them tomorrow. Have a great night, guys.
Bye!